Alright, so this video we're going to be, I guess we're just really solving systems. Now before we solved systems of linear equations, now we're going to be solving systems of, it could be linear, but mostly, the focus is going to be quadratic. So solving systems with a quadratic sometimes it's going to have a quadratic and a linear. It might be two quadratic equations that we're solving a system for. But the focus today is not really going to be linear systems. But remember, a system is pretty much just multiple equations in one group that share the same variables. So if you're going to solve it graphically, actually I was not very ready to make this video, so I'm going to walk in front of this real quick. If you're going to solve it graphically, that's the easiest way to solve a system because you're just looking for where they actually intersect each other. So let's go ahead and do this first one real quick. See if we can focus decently well, I guess. All right, so we'll try it. If I'm going to solve this system, I need to make sure I solve for y first. Both of these are actually solved for y. Once I do that, I'm going to go ahead and graph both equations, and I'm looking for where they intersect. So 0.5, get x plus 2 squared. So if you're confused about what I'm doing, I'm graphing both of these right now. And to solve a system of equations graphically, you're looking for their intersection points. If they don't have an intersection, in this case, then the solutions should be imaginary. Okay, because we're still dealing with quadratics. All right, so let me zoom in. Now that I've graphed that, I'm just going to zoom in on the calculator because I think this thing is having trouble focusing on two different elevations. Okay, so here we go. So I'm going to analyze graph. I'm looking for the intersection. So one intersection is at 0 and 2. So one of my solutions is at x equals 0. And the other solution is going to be, I'm guessing, at negative 2. But let's just find out. Yeah, negative 2, 0. Okay, so my two solutions for this system that we just graphed, it's at x equals 0 and x equals negative 2. Those are my two solutions. And it's as simple as that. You're just graphing it and you're finding the intersection point. All right. Now, if you look down here, further down and to the right, it says solve the system of equations by substitution. So we've done this before, but we've done it only with linear equations. It's a pretty easy concept, really. So you're just substituting in one of your variables into the other equation. So I don't know which one I'm going to solve here. I guess I'll probably do number 13. So I'm going to take this, number 13, and I'm going to solve it for one of these variables. This y looks really easy to solve for. So I'm going to solve for y, and then when I have solved for y, I'm going to plug into the other equation. So let me just rewrite real quick these equations. So I've got 2x squared plus 4x minus y equals negative 3. And then I have negative 2x plus y equals negative 4. All right, so here's my equation that I'm trying to solve using substitution. I'm going to start off by solving this for y. So I'm going to actually end up having y equals 2x minus 4. All right, so having solved this now, I'm going to go ahead and plug or substitute, that's why it's called solving by substitution, that equation where it says what y is. It says y is 2x minus 4. And instead of writing y here, I'm going to write 2x minus 4. So my new equation that I'm going to be solving should look like this. 2x squared, that's coming from here, 2x squared plus 4x minus, now instead of writing y, I'm writing what y is. It says y is 2x minus 4. So here's my y. and it equals negative 3. So I have 2x squared plus 4x minus y, so minus, there's y, equals negative 3. And then I'm just going to solve it from here. So I have 2x squared plus 4x minus 2x plus 4 equals negative 3. And notice what I did here to get from this equation to this equation was I distributed the negative. A lot of people just kind of forget that negative there, or maybe they just apply it to the 2x. It gets distributed into that parentheses. So that becomes a negative 2x, and the negative 4 becomes a positive 4. All right, combine like terms and also set it equal to 0. So I have 2x squared plus 2x plus 7 equals 0. That's combining all my like terms, also setting it equal to 0. Now from here, I can solve using the quadratic equation. I can solve, I don't know if I can factor this and solve it. So it looks like I can solve using the quadratic equation. If you really wanted, I guess you could do complete the square or something like that, but I would just stick to the quadratic equation. So you got negative b plus or minus the square root of b squared minus 4ac over 2a. And that's what x is going to equal. So x equals negative b is going to be negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times a is 2 times c is 7, all of it over 2 times a, which is 4. All right, so I've got 4 times 2 is 8 times 7 is 56, so 4 minus 56. This looks like it's going to be an imaginary solution. The square root of negative 52 over 4. And honestly, for this video, I'm just going to stop there. But the truth is, you could also take, well, remember I told you if you have this negative under there, it's an imaginary solution, so you put an I on the outside. So you have negative 2 plus or minus I square root of 52 divided by 4. And you could actually, I would pretty much guarantee that you could reduce this if you wanted to some. But I'm going to go ahead and stop there. But that would be your solution using substitution. Next type is finding your solutions using, right here, using elimination. So on number 17, it asks you to use elimination. So I'm going to go ahead and do one of those for you real quick, and then that'll be the end of this video. So first thing I'm going to do is just copy it down. 2x squared minus 3x minus y equals negative 5. Negative x plus y equals 5. Okay, so this has already been written for you in such a way where you're ready to use elimination. If it looks like, say number 18 right here, or number 19, you're going to have to do some rearranging here. So the way you want to actually rearrange your equations in order to do elimination is you're going to want any number that's by itself, any term without a variable. So just the numbers all on the right side of your equations, and then all of the variables on the left side, and in order. So notice my x's match up, my y's match up, my x squareds, if I had another one here, they would match up as well. So once it's like this, you're ready to go ahead and try elimination. Now remember, elimination is the idea that you can multiply an entire equation by some constant, right? So that when you add them together, they could eliminate. So I could eliminate my x's by multiplying this bottom equation by negative 3. Okay, I'm going to erase everything I'm doing right now in a second, but I'm just explaining the concept. And if I did that, I would end up having, on the bottom equation, I'd have 3x, and then I'd have minus 3y equals negative 15. So when I actually, now this is done, that's been the equation that's multiplied by negative 3. When I add them together, notice my x's would cancel. So I could do that, but the thing is, if I did that, I'm actually creating a lot more work for myself than I have to. So let me erase this. Let me show you what I'd actually do. But that is a method. And again, there's so many methods of solving things, guys. You just need to make sure everything that you're doing is algebraically savvy. Like you can actually do that, algebraically speaking. Now, when I look at this, honestly, I just see a negative y and a positive y, which they're ready to cancel already. I don't have to do anything. So I'm just going to add them straight together. They cancel out. So I have 2x squared, negative 3x minus plus a negative x is going to be negative 4x. And that's going to be equal to negative 5 plus 5 is just 0. All right, so now if I'm going to solve this, I can solve this. It's set equal to 0. I could use the quadratic equation. I could factor it. I'm going to go ahead and factor it. Again, the quadratic equation always works, guys, but sometimes factoring just makes it easy as heck if you can do it. So if you knew that this gets factored to that, well, the whole equation's already solved for you. If you didn't, you'd have to use the quadratic equation, which would take you a little bit of time, but you'd get the exact same answers. Keep in mind, if you're using the quadratic equation, your C value here is 0. There's a plus 0 there. But anyway, having factored it, the only possible way that these two things can multiply together and get 0 would be as if 2x were to equal 0. And if 2x equals 0, that means x equals 0. Or if x minus 2 equals 0. And if x minus 2 equals 0, then x would have to equal 2. And those are my two solutions. So that's by elimination. Guys, guaranteed if I solved it using substitution, I would get the exact same answer. If I solved it graphically, the intersections would be at x equals 0 and x equals 2. So there's 3 different ways of solving this. In my opinion, I think graphically is always the easiest way to solve. Okay? So real quick, just to end the video, if I'm solving graphically, I'm looking for, here's a parabola, here's a line. This intersection and that intersection are my solutions. Potentially, maybe the line goes like this instead, and it hits the parabola in one spot. It just hits right there. Okay, and if that's the case, then you've got one solution at the intersection. If it doesn't hit, then you have 2 imaginary solutions. Okay, anyway guys, I'll see you in class.